So our new unit is dealing with sequences, which a sequence, as you can see my little definition here, is purely a list of numbers with a pattern to them. So I gave you a sequence up above. I gave you a sequence of 1, 3, 6, 10, 15. So some other vocabulary words we have here is the number 1, because it's in the first spot, would be our first term. So then the number 10 would be our what term? Nope. This is my first, second, third, fourth. So 10 is my fourth term. Now what does that dot at the end mean? It continues on. And what they like to refer to that as is your nth term. So they're just saying that they could ask you for some term beyond what they've already given you. They just don't know which one they're going to ask you for yet, so they refer to it as your nth term. Now the thing about sequences is you could still write them as a table of values like you're used to seeing. So if you write it as a table, your term is like your x value. And the actual sequence itself, that's kind of like your y value. So if I were to write this sequence over here as a table, I would have 1, 1, because my first term is the number 1. 2, 3, because my second term is a 3. 3, 6. 4, 10. And then 5, 15. That's what our table would look like. So again, your x column is your term. The sequence itself would be like your y values there. So whichever way you want to put it, you can. You can put it as a table. You can leave it as your little sequence list that they gave us. So again, term, that's just each member of the sequence is referred to as a term. They like to use the letter n now, which that just means what position in the sequence you're referring to, or what term. So if they say your n is a 4, that means you're looking for your 4th term. If they say n is a 10, you're looking for your 10th term. So our notation that we use is that little in that a n there. We read this as a sub n. That's how we read that there. So that just refers to whatever term you're looking for. So if I ask you for a sub 3, that means I'm looking for my 3rd term. So if we go to our sequence, what's our 3rd term? 6. So a sub 3 would be a 6. Let's say I asked you for a sub 2. That means I'm looking for which term? Which term are we looking for here? The 2nd term, which is a 3. So that little n just tells you what term are we looking for. Now there's a couple of other notations here. We're going to deal with these in a couple of pages. A sub n minus 1 refers to your previous term. A sub n plus 1, that's your next term. As I said, we'll deal with that in a little bit. So still dealing with that same sequence we have up above. What is a sub 4? 10. I wrote it right over here for you. So if you are asked to write that in words, a sub 4 equaling 10 means that 10 is the 4th term. Or the other way you could write it is the 4th term is 10. Doesn't matter which order you say it in, it means the same thing. Because our 4th term in our sequence up here, 1st, 2nd, 3rd, 4th term. Yeah. No, that's fine. Okay, so they want to know 15 is in what position. So if you look at your sequence up above, 15 is in which spot? The 5th spot. So 15 would be our 5th term. Our n would be a 5 for that.
So could we write it A to fit this answer? Or A sum?
You could, but they didn't ask you for it that time. They were just asking what position is it. So then a sub n equals 21. They want to know what n is. Well, is 21 even on our list? No. Well, let's see if we can figure out our pattern here. How do I get from 1 to 3? 2. Plus 2. 3 to 6?
3.
6 to 10?
4.
So what is our pattern? They keep adding what each time?
4.
They keep adding one more. So this one's plus 5, so then plus 6 would give us what? 21. So which position is 21 in? It would be our 6th term. So n would equal 6. So the rule for our pattern up above is given to us here. A sub n equals 1/2 n squared plus n. They want us to find a sub 7. So again, what letter do we normally have where that 7 is? We normally have an n. So really what they're asking us for is, what is it when n equals 7? A sub 7 is the same as asking, when n equals 7, what does this equal? So all we have to do is plug in a 7 for all of our n's. So a sub 7 equals 1/2 7 squared plus 7. So what is 7 squared plus 7? Yeah, 49 plus 7, which is 56. And what's half of 56? 28. So a sub 7 equals a 28. So because this rule can give you any number in the pattern, we call this an explicit formula. If they wanted to know the 50th term, we could easily plug in 50 and actually figure out what is our 50th term. If they wanted to know the 23rd term, we could easily figure out our 23rd term just by looking at the formula. So that's why it's called an explicit formula, it's because you can look at each individual term and find it out on its own. So our example here, they give us an explicit formula. They want us to write out the first 4 terms of the sequence. So I'll make myself a little list. Term 1, 2, 3, 4. I got to find the first 4. When we're dealing with our sequences, our first term is always the number 1. So we're going to plug in a 1 for all of our n's. So a sub 1 would equal 1 minus 1 over 1. So what is 1 minus 1? 0. And 0 over 1 would be 0. So the first term of our sequence would be a 0. So now we'll find term 2, plugging in a 2 for all of our n's. So a sub 2 would equal 2 minus 1 over 2. Which 2 minus 1 gives us what? 1. And then over 2 gives us 1/2. So our second term is 1/2. So now for my third term, what are we going to plug in? 3. So 3 minus 1 over 3. What would our third term be? 2/3. And then our fourth term, plugging in our 4, it would be 3/4. So the explicit formula makes it nice and easy for you to be able to sit there and figure out what are each of your terms going to be. So So taking a look again, the same list we had up on the front at the top. What is a sub 5? Well, that means the number in the 5th position, which is 15. I wrote that out for us already. So what position is the number 6 in? Here's the number 6. What position is that in? The 3rd position. So then what is n for the term 21? That's the one we figured out on the front. That was our 6th term. So n would equal 6. And again, we have our rule there. A sub n is 1/2 of n squared plus n. They want you to find a sub 8. So let's have you go ahead and find a sub 8. Plug in your 8. $36. All right, so our next example, we have the pattern 1, 2, 6, 24, and 120. This pattern is a little trickier to figure out. 6 is equivalent to 3 times 2 times 1 when you multiply them all out. 24 is the same as 4 times 3 times 2 times 1. These are a special kind of products that we refer to as factorial. Have you guys heard that word before? Yeah. So what a factorial does is it takes that number and it multiplies it times every number smaller than it until you get to a 1. So with this pattern, to get 1 is that is 1 factorial, which our factorial is a little exclamation point. It's not an excited one. It's 1 factorial. So 2 factorial would be 2 times 1, which gives us our 2. And then as we said over here, 3 factorial, which is 3 times 2 times 1, is how we get our 6. And then 4 factorial gets us our 24, because it's 4 times 3 times 2 times 1, as I have written out there for you. 5 factorial gets you your 120, and then so on and so forth. So they just keep doing factorials with that. Here is our rule for that. A sub n equals n factorial. I show you this only because I don't think they would actually have you come up with that ruling. They wouldn't have you come up with a factorial in there at all. But you need to know how to be able to use the factorial. So let's say we were trying to figure out 20 factorial. Nobody really wants to sit here and type into their calculator 20 times 19 times 18 times 17 times 16 times 15 all the way down to 1. It's a little redundant. So the factorial button is in your calculator. It's under Math. You would arrow over to your PRB, which stands for probability. And then it's your choice 4. So what I want you to do is I want you to practice that. Find your 8 factorial. I don't think your calculator will actually do 20 because the number is way too big. But I want you to practice doing 8 factorial. So you got to type in your 8 first, and then do the math over to PRB, choice 4, and it'll get you your answer. If you did it right, you should get 40,320. So if 8 factorial is 40,320, 20 factorial is going to be like ridiculously huge. Yeah, it gives you the little e to the, e to the 18, yeah. So it means it's like 10 to the 18th power. They're putting in scientific notation for you. Yeah. So then we have a very special sequence called the Fibonacci sequence. Has anybody heard of the Fibonacci sequence?
I like that.
You like the name? Yeah, it's a pretty cool sequence. So that's the sequence 1, 1, 2, 3, 5, 8, 13, which the way you keep figuring out the next terms of your sequence is you add the two terms before it. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So you add the two terms before it together, and that gives you your next term. What I think is really cool, though, is when you take your Fibonacci sequence, the way it actually looks is that's your little spiral like in a seashell. Or if anybody watched the recent episode of Big Bang Theory, it was on Sheldon's shirt. And I got so excited. I was like, look, honey, it's the Fibonacci sequence. And my husband just looked at me like I was weird. But, what? How can you not like the Big Bang Theory?
It would be fine if they got rid of it. I would like to
All right. So what they want us to do is they want us to prove that a sub 1 does in fact equal a 1, given your explicit rule for your Fibonacci sequence, which is that little formula up there. It is. I agree. So what we're going to do is we're going to plug in a 1 for all of our n's. So every single n in that formula, which there are 3 of them, we're going to plug in a 1. So it's 1 plus the square root of 5 to the first, minus 1 minus square root of 5 to the first, all over 2 to the first, radical 5. So since all of our exponents outside of the parentheses are a 1, is there really anything for us to do there? No, we're not multiplying it all out. So what do I have to do with my subtraction sign here? Distribute it through the parentheses. So that's a negative 1 and a positive radical 5. So 1 minus 1 does what? Cancels each other out. 1 minus 1 would be 0. Square root of 5 plus the square root of 5? 2 square root of 5. And then 2 to the first is just 2 square root of 5. So anything over itself equals 1. All right, so now they want us to prove that a sub 2 equals a 1. So now what are we going to plug in for n? 2. So that's 1 plus the square root of 5 squared minus 1 minus the square root of 5 squared all over 2 squared square root of 5. So this one does take a little bit more work, because if we're squaring this, that means we have to write it out twice. 1 plus the square root of 5 times 1 plus the square root of 5 minus 1 minus the square root of 5 times 1 minus the square root of 5 all over 4 square root of 5. No, we don't have to use it a lot. So 1 times 1 would give us a 1. 1 times the square root of 5 would give us what? Square root of 5. Square root of 5 times 1. And then square root of 5 times square root of 5 would be 5. So now we need to multiply that other one out. 1 times 1. 1 times negative square root of 5. Negative square root of 5 times 1. And then negative square root of 5 times negative square root of 5. Positive 5. And again, that's all over 4 square root of 5. I'm sorry, Paul, I don't mean So now, what should we do with this negative sign again? Distribute, so that's a -1, positive radical 5, positive radical 5, and a -5. So let's combine all of our like terms. What happens with our 1s? 1 and -1. Cancel. 5 and -5. Cancel. So then we're left with 1, 2, 3, 4 square root of 5 over 4 square root of 5, which equals a what? 1. So it does work out. I mean, kudos to Fibonacci for figuring that all out, but luckily, if you're just looking at the sequence, it's pretty easy to figure out the next term. All right, so now we're going to move into the other way of being able to write our sequences, which is in the recursive form. So now we're going to deal with the sequence 1, 3, 5, 7, 9. And the rule for that is a sub n equals a sub n minus 1 plus 2. So the way we read that is your term equals, so whichever term you're dealing with, whether it's your second term, third term, 20th term, your term equals this notation right here, a sub n minus 1. That means your previous term. So this is our previous term. And then what are we doing to it? Adding 2. Previous term plus 2. So the thing that people get stuck on, though, is that notation, a sub n minus 1. So if they told us to find a sub 7, the thing with the recursive formula is you can't figure out your 7th term until you know your 6th term. But you can't figure out your 6th term until you know your 5th term. So you always need to know that term before it. So if they're asking you to find your 7th term, you need to know all 6 terms before it. Because to get your 6th, you need to know your 5th. To get the 5th, you need the 4th. 4th, you need the 3rd. All that good stuff. So if you were to work it out, right here, this is me working everything out the long way for you guys in an example. When you plug 7 in for your n's, and you subtract it down there, that gives you your a sub 6. That's why it's our previous term. It tells you to go back to that other one. So we happen to know that a sub 6 was 11, so then 11 plus 2 gave me my 7th term of 13. So you could always go through that process of plugging it in and then subtracting it and then remembering, oh yeah, it's my previous term. Or you can just remember that whenever you see a sub n minus 1, that means you need your previous term. So what do you think a sub n plus 1 would be? That would be your next term. So a rule that gives you any number in the pattern based on the previous number, that is what we call recursive. So if you need to know the term before it, that's a recursive formula. So down here, we're going to practice again an explicit formula, and then we're going to go through recursive formula so you can kind of see the differences between the two. So explicit, they told us to write the first 3 terms of our sequence. So I'm going to put my little 3 lines. I got to find my first 3 terms. So we'll start with our first term. What do we plug in for n? A 1. So a sub 1 would be 1 squared plus 1, which, what does that give us? Yeah. All right, so our second term would be a sub 2, so that's 2 squared plus 1, which, what is 2 squared plus 1? 5. And then our third term, 3 squared plus 1, which would be 10. So our first 3 terms are 2, 5, and 10. So with this formula, explain how to find the 10th term. That phrase explain means you have to write words. On your Regents exam, when you see explain, you got to write words. So how would we find our 10th term? What would we do? Plug 10 in for n and then simplify. All right, so example 2, they want you to find a sub 5. So I'm going to give you guys a minute. I want you to find a sub 5. Plug your 5 in. A sub 5 equals 35, because it's 5 times 7, which gives us 35. All right, and then down below, write an explicit rule for the following sequence. So again, you have to keep in mind, this is term 1, term 2, term 3. So how do I make a 1 turn into a 3? Now, is that the same for 2 plus 2 to give me 6? No. It's got to be the same rule all across the whole sequence. So how else can I make a 1 into a 3? Times 3. Is 2 times 3 6? 3 times 9, 3 times 3 9? So then our sequence would be 3 times whatever the term is, so 3 times n. I will show you guys a different way to write our sequences as we go along. That's the basic one. So let's take a look at our recursive formula over here. So they want us to find the first 3 terms of this sequence. Here's our recursive formula. Now, the one thing about the recursive formula is they always have to give you your first term. So this a sub 1 equals 3, that is our first term. So when they tell us to find the first 3 terms, they already give us the first one. So really, how many terms do we have to find? 2. So to find our second term, so our a sub 2, again, this notation right here, that means you need your previous term. So my previous term was a 3, and then I need to add 2 to it. So what is 3 plus 2? 5. So our second term is a 5. So now to find our third term, again, I need my previous term, which would be the 5. I'm looking at my third term. My previous term would be the second one. And then I have to add 2 to it. So what is our third term? 7. So 3, 5, 7, those would be our first 3 terms. So with our recursive sequence, explain how to find the 10th term of the sequence. How would we find our 10th term? What do we need to know in order to find our 10th term? I guess should be my question. We need to know the 9th term, but to get the 9th term, we need to know the 8th term. So we got to find, bless you, first 9 terms, then add 2. So now example 2, we're given a different recursive formula. Again, a couple of things that hint to you that you have a recursive formula is that notation right there where you have the a sub n minus 1. As soon as you see that notation, you need to think to yourself, okay, I have a recursive formula here. Your other hint it's recursive is the fact that they tell you what your first term is. They always have to give you your first term because you can't find anything out without knowing at least that. But they want us to find our third term. But as we know, what do we need to know in order to find our third term? Our second term. So we got to find a sub 2 first, Then we can figure out the third term. So reading through our recursive formula over here, this says 3 times your previous term plus 2. So 3 times my previous term, which was negative 5, plus a 2, would give us a what? Negative 13. So now we can find our third term, which is the one they actually wanted. So again, it's 3 times my previous term plus 2. So 3 times negative 13 plus 2. So what does that give us? Negative 37. Now see, what they like to do on your Regents exam is they give you a multiple choice question similar to that, and then they tell you to find the 5th term. So it's quite a bit of work to actually get the answer, because you got to find the 2nd term, 3rd term, 4th term. Then you can finally get your answer of the 5th term.
It's so easy and fast.
It is.
And
Yes.
you can also do a lot of this in the calculator on the Regents.
Yeah, but I mean, you still have to go through the steps of finding your other terms first. Yeah. So down here, they want us to write the recursive rule for the following sequence. So again, one of the key components of the recursive rule is you always have to identify what is your first term. So what is our first term in this sequence? 27. So a sub 1 equals 27. And then if we take a look, what happens to get 27 to 24? And then 24 to 21? Goes down 3. So we're taking our previous term, which would be a sub n minus 1, and you subtract 3 from it. And that would be our recursive rule for that one. So then our last page of our notes here is just simply telling you that our sequences can also be written in function notation. So instead of our a sub n, we could actually use f of n, and it means the exact same thing. It doesn't matter which one they decide to use that day, it's the same thing. So for this one, they used function notation, but it is still a sequence. They also will always give you a hint that you're dealing with a sequence. They generally put those words in there for you. So all we have to do is plug what in for n? 1, and then 2, and then 3, and then 4.
Do we have to remember all these formulas?
No, because these are all different formulas given specific sequences. I've not given you a formula yet to memorize. So f of 1 would equal what? 2. So I'm going to put 2 in my table. F of 2 would be 5. Let's have you figure out f of 3 and f of 4 if you did not already do so. What would our f of 3 be? And f of 4? 17. So it follows the same rules as our explicit formula with our a sub n. Same thing goes with recursive. You can still do recursive using your function notation. It would have this notation in it, which also still means your previous term. When you see that n minus 1, you got to be thinking in your head, you're dealing with a recursive formula. It's a previous term thing. So for this rule, we're always taking our previous term and doing what to it? Adding 6. So our first term is negative 5. I already put that in the table for us. So what's negative 5 plus 6? 1. And then plus 6. And then plus 6. There we go.
There's a previous term, right? It's 1 plus 6.
No. the f of n minus 1 is telling you to go to your previous term and just add a 6 to it. So you should be able to write a rule for your pattern of numbers in all 4 of these different ways here. Your a sub n explicitly, your a sub n recursively, your function explicitly, and then your function recursively. Yes. So I'm going to give you a hint. Your explicitly, whether you write it in a sub n or f of n, it's going to look exactly the same. And then your recursively, those are also going to be the same. So we're given the example of 7, 4, 1, and that's a negative 2. I don't know why the negative sign looks weird. If you like using the table, please feel free to do so. 7, 4, 1, negative 2. So they want us to write it in all 4 of those ways. So I'm going to start with the first one, a sub n explicitly. So when I look at my table here, these numbers are all decreasing by what? Negative 3. Now, it could be just because I've been doing math for a really, really long time. But to me, I automatically see that that is a linear pattern. It's always decreasing by 3, which tells me it's a line. So when I know that it's a line, I think to myself, mx plus b, where our slope would be a negative 3. So it would be negative 3 times your term. But we also need to know what? We have to know where it starts, which normally our start would be a 0. So if I just work my way backwards, what should 0 be? 10. So negative 3n plus 10. Now, if it wasn't always a negative 3, it wouldn't be linear, and I wouldn't use my mx plus b, but this one happened to be that way. All right, so my second way they want us to write it is a sub n notation recursively. So a sub n, as soon as I hear recursively, I automatically go to my head and think, okay, I got to write my first term. What is our first term of our pattern? 7, so a sub 1 equals 7. Always have to have that there. And again, we're taking our previous term and we're doing what to get to the next term? So a sub n minus 1, and we're subtracting 3 from it. So previous term minus 3, then minus 3 again, then minus 3 again. All right, third way is our function notation explicitly, which, as I said, is exactly the same as your a sub n. It's just you'd write f of n equals negative 3n plus 10. The only thing that's different is the stuff at the beginning. And then our function notation recursively. Again, we would start with f of n instead of a sub n. You would still have to write your first term. It's just you would write f of 1 equals 7 instead of your a sub 1 equals 7. But again, it's our previous term, which would be f of n minus 1, and then you subtract 3 from it. So you got to remember that notation, n minus 1, that tells you it's your previous term.